now, past the vocab, we are going to look at area, circumference, arc length, arc measures, angle measures, lots of different things related to this. Let's just start with some review of area. Area formula for a circle. Area equals pi r squared. Circumference equals 2 pi r, or if you wanted to do instead of 2 radius, we could just say pi times diameter. Find the area and circumference of a circle. Use the calculator's value for pi. Okay. So round to the nearest tenth. You have the radius, so we're going to do pi times 11 squared. Type that in using your pi button. Check math. We have 380.1. And that would be in centimeters, so we'll do centimeters squared with area. Circumference is like perimeter, it goes around the outside of it, so I will do 2 pi times 11. So that would be the same as 22 pi. Sometimes you'll see, like on the ACT, they leave it in forms of pi instead of writing it in decimal form. So if you ever see them write something like 22 pi, they just took the radius times 2, or that's the diameter. But since we're doing decimal form here, we're going to say that's about 69.1, and that would be centimeters. So this is our circumference, this is our area. Okay. If you're given the diameter, two choices. We still need the radius to find area, so divide it by 2. 7.4 divided by 2 equals 3.7 is the radius. Okay, so now you can use the same formulas. Area equals pi times 3.7 squared. And you get 43.008, so I'm just going to do 43.0. And then, I guess that's inches squared for area. Circumference is 2 pi r. Or you could just use 7.5 pi, since that's the diameter. And that comes out to 23.24, so we'll say 23.2. Alright, so that is our circumference, and that is our area. Alright, let's look at the next one. A central angle, we talked about what that means. A central angle is an angle with its vertex at the center. Just write that definition of the circle, and its two sides are radii. Remember that funny spelling? The sum of all the central angles in a circle all sum up to 360 degrees, which we also have talked about that before. An angle sums to 360. So in this particular picture, an example of a central angle would be angle ABC. It is located at the center of the circle. The degree of the arc is formed by the endpoints of a central angle is equal to the degree of the central angle. So the arc out here is equal to the center in there. So let's write this a little easier. Look at something real fast. You're going to get a formula sheet next time. We might as well make it look the same. So, for instance, the central angle is equal to its arc. So in this case, arc AC would be 84 degrees. If you want to find ADC, the major arc, you just take 360 minus 84. That would be everything else is 276. So that is what a central angle is. It's at the center. It's equal to its arc. So this one has us used, goes both ways. So in this picture, UXV. UXV. Alright, well there's not a number there to go with, so let's see if we can fill some other things in. What do we know? So I know this angle here is 72 degrees because that arc is the same, and this is 87 degrees because that arc's the same. So if you notice, this makes a straight line. A straight line is 180 degrees, so if I take 180 minus 72 minus 87, we have 21 left. So this is really 21 degrees out here, or 21 degrees there. Hopefully you guys remember things called vertical angles. This angle here should be equal to that angle there, because those are considered vertical angles. So this is also 72 degrees. Let's see, am I getting closer? UXB. UXB. Hey, that's 72 degrees by vertical angles. Arc ST is that little arc over there. Again, I took the straight line 180 minus what we were given, and that's how I got the 21. WV. So I need to find this arc here. So if you take 360 minus the rest of that stuff, we could figure it out. You could also do 87 and 21, add those up to get that big angle. But lots of ways to do it. This arc is 108 degrees. Okay, so TW, the small arc TW would be adding these two numbers together, so that should be 93. And now we want a major arc, TVW. TVW. So it's everything except for that. Or we can just add up these ones on the outside. 87 plus 72 plus 108. We get 267. So key thing there, the center angle is equal to its arc. Alright, now let's look at, so that was called arc measure, and this is called arc length. So arc measure measures like the degrees. Arc length would be taking like a piece of string or something and trying to literally just measure from, say, this point to this point around the outside. So you're trying to find, like, if you took a piece of string, like circumference, and measured around the outside here, how long would that piece of string need to be? So what you do is you're taking not the whole circumference, because we're only taking part of the circumference. So arc length is a portion of circumference. Arc length formula is this fancy looking cursive L equals x degrees over 360, because it's a fraction of the circle times your circumference, which is 2 pi r. That fraction you are looking for is called, this angle here, x degrees, is called the central angle. Okay, so in this case, our central angle they drew was 315 degrees. So the arc length would be 315 out of 360 times your circumference, 2 pi times 11. So you can do 315 divided by 360 and get a decimal, and then just times that times 2 pi times 11. And it comes out to 60.47, so nearest tenth would be about 60.5. And this is circumference, so we'll just say feet. So now you see the arrows on the inside here, arc length of 150 out of 360 times your circumference, so 2 pi times 19. 150 divided by 360, the decimal, and then times that by 2 pi times 19 equals about 49.7. And sometimes they may give you stuff in a word problem instead of a picture. Says we have a circle with radius of 8 and a central angle of 45. Find the length, so that's the L one, of the intercepted arc. An intercepted arc is the arc where that angle is formed by. So this right here, from here to here, is the intercepted arc of that angle. It means those two sides that make the angle intersect that to create that arc. So, you just take your degrees, 45 degrees over 360 times 2 pi r. 45 out of 360 is a decimal times the circumference, which is about 6.28, so we'll say about 6.3 centimeters. Alright, so that's arc length. It has the fancy L. It's a fraction of the circumference measuring around the outside. Area of a sector is, instead of measuring the length around the outside, area represents, okay, now I want to find that piece of the pie, but I want to shade it in with area, not just the outside, not measuring around it, but filling in that piece of the pie. How much area is that? So you're taking the same idea, the fraction of the circle. We used x, they used theta, it's not a big deal. And then you have pi r squared. So this is the area formula. It's still the same fraction, but it's the fraction of the area instead of a fraction of the circumference. So this is your central angle, which would be 150 out of 360 times pi r squared. So you're finding the area and you're taking a fraction of it. So this area is about 11.78, so we'll say about 11.8. If you ever see this one worked out by hand and leaving it in terms of pi, you would take 150 divided by 360 and then times that by 9, because 3 squared is 9. Put that in fraction form. It would be like 3 3/4 pi. Times 9. So it would be like 15/4 pi. Just so if you ever, there's some places in this chapter we're going to leave it in pi form, some places we're going to put it in decimal form, so it's really just reading your directions. The 9 came from the 3 squared, that's where I got that. Alright, this just says round to the nearest 10th. Area formula, we're going to take 23 as the central angle, so 23 out of 360 times the area formula is pi r squared, the radius is 14. And the same area, I have about, it looks like 39.3. And area is in units squared, so that should have been meters squared. This one would be inches squared. Alright, the last one is taking kind of what we knew about regular polygons. Regular polygons inscribed in a circle has a radius of 8. Sounds like we did last chapter, right? We have a radius of 8. Find the arc length between any two adjacent vertices. So we are trying to find this length here. In order to find that length, we need to know the central angle. Because remember, the length formula is x over 360 times 2 pi r. So to figure out the degrees, that central angle, you take 360 divided by 5, because there's 5 sides, or 5 triangles formed, equals 72 degrees. That is your central angle. So we'll do 72 degrees out of 360 times 2 pi times 8. Arc length formula. They want you to find the arc length. I have about 10.05 or 10.1. Length is just in centimeters. We don't square it because it's not area. Alright, so we covered a lot of vocab today. We covered arc measure is equal to the angle, arc length is a fraction of the circumference, and area of a sector is a fraction of the area.